Now let's look at part E. We have x equals to 0. Then in the body we have while x equals 0, do x equals x plus 1, and then we have x equals 1. Now using the rule for while, we say P while the condition do s, and then we have P and the negation of the condition. Then what do we have in the rule for while? We have P and C, S, P. So we have P and C, S, P. Okay, now let's apply the assignment rule. X equals 0, Q, E over X, x equals E, Q. And then we assign the value of E to X. So x plus 1 equals 0, x equals x plus 1, x equals 0. So as you can see here, x plus 1 equals to 0. That means x equals minus 1. So when we add 1 to that, we get x equals to 0. So this is valid. So we have used the rule for while and assignment here, and also we have performed precondition strengthening and post-condition weakening here. So let's add those as well. We have x equals to 0 and not 0 this. So we have weakened this to x equals 1. We have x equals 0 and x equals 0. X plus 1 equals 0. We can say that part E is also valid. Even by looking at it, just by looking at it, we can say x is initially 0. So while x is 0, what we do is we add 1 to x. So finally, x will be 1. So this is anyway valid. Okay. Now let's go to question number 2. If is the following specification true? Okay, so we have a whole triple, which is a compound triple. Which is a compound triple. As you can see here, we can separate this whole triple into 3 separate triples. So let's go ahead and do that. So what we use to do this is rule for composition. So what they've given is x equals x. So what has been given is x equals x, and Okay, so let's write 3 separate Hoare triples using this. So the post condition of the first one will be the precondition of the second. Post condition of the second will be the precondition to the third. Okay, so this is what we have. Now we need to apply assignment rule to these 3 Hoare triples and find the preconditions and the postconditions of each of the 3 triples. So I'll name these separately. Let's say this is the first triple, the second and the third. I'll take them separately because it's easier to explain in that method. So let's first choose the first one. So I have Q2 y equals x and x equals y. Now when I apply the assignment rule, what I have is Q E over x, x equals E Q. Okay, then I replace x with E. X is replaced with E. So here I have this. X equals 1. Okay. So now as you can see, I have found out what Q2 is. This is what Q2 is. So Q2 is the precondition of the first Hoare triple, and it will be the post condition of the second Hoare triple. So now I'll go to number 2, and in number 2 I know what this is. So since I know that, I can find what this is. That's what I'm going to do. And then once I find that, I'm going to apply that here, and then I'll be checking if this will be the resulting precondition. If that's the case, then this is a valid Hoare triple. So let's take the second one now. So the second one goes like this: Q1 x minus y Q2. So let's replace Q2 with what we found before. Y equals x minus y. Okay, now let's apply the assignment rule. E over x y equals this and q. Okay, now let's simplify by applying e's value to x. So I hope it's clear that in this case x is y. Y is the letter that we choose as x. So we have this, and y equals y. So what happens here is we have x minus y. This is what we have. So what's remaining is plus y. Then we get, and then finally we have, okay. So again, as you see, now we found out what Q1 is, which is the precondition of the second and the postcondition of the third. So now I'm going to consider the third one. Okay, third one goes as x equals x and y equals y, x equals x plus y, q1. Okay, so now let's replace q1 with what we know. Q1 is what we found before, x minus y, y equals y. Now let's apply the assignment rule. Q e over x x is e and we have q. Now let's simplify by applying e to x. So when we apply e to x here, we have x plus y minus y. So what we get is x equals to x, and y equals to y. X equals x plus y. And again here, we have q. Okay, now as you see, this is what we get as the precondition, and that is the precondition which is given over here as well. So we got the same answer after applying the rule for composition and the assignment rule. We got the same answer as the precondition of the third Hoare triple. Hence we say that the specification which was given in the question is true.